Hi viewers, welcome to this class on replacement analysis, 5th unit of your course Engineering Economics. The entire portion of this unit 5 I have divided into two parts. Today let us learn first part and the second part we will see in the next video. Consider any organization manufacturing the products. For this, it uses various facilities, out of which 4 are very important, which we industrial engineers call as 4 M's. That is man, machine, money and material. 2 more M's are also added now, methods and measurements. These are very important and play significant role in the manufacturing as they are directly involved. So today let us focus on equipment and machinery, one of the important facilities directly involved in manufacturing the products. These facilities should be continuously monitored to ensure their efficient functioning, quality of the products are not lowered, operation and maintenance cost does not increase with time, and that some equipment which produce the products that have shorter life cycle will become obsolete over a period of time if not given attention for long time. So important takeaway is that it is an absolute necessary for an organization to maintain the equipment in good operating conditions to be economical or to be optimal as well. If a firm wants to be in the same business competitively, producing the same products, the management often faces a few problems. Important of them is decision making problem, that is whether to retain the old machine or to replace with a new one, a more efficient one which is available in the market. The management would have purchased the equipment few years ago, and today due to continuous improvement in the market, more sophisticated, still better, with more features, easily operatable is available. So a kind of dilemma will be there for the management whether to go for the new one which is available at the same cost as the cost of the old one today. So which one to go for? Maybe the purchasing cost is high for the new one, but operation and maintenance cost is less. Whereas for the old one, the operation and maintenance cost would have reached its peak. This is an important decision, and if not properly taken, results in slowdown or shutdown of the operations or ultimately loss or failure of the business itself. These decisions come under the category of replacement problems, and they make use of economic analysis, wherein cost data of all the alternatives available will be considered and analysis will be made, and ultimately the correct decision will be taken based on the results obtained. So what are the costs considered? The first cost, nothing but the purchase cost of the equipment, salvage value, on disposal of the equipment. Some may be meager, but some amount will be obtained as into the pocket of the owner of that asset, which we call it as salvage value, and operation and maintenance cost which will be incurred every year to keep the equipment in good condition. So the important takeaway out of this slide is, what are replacement problems? If this question is asked, the answer is replacement problems are decision making problems involving the replacement of existing, obsolete or worn out assets by the best challenger available in the market. So these decisions answer to the important question, when to replace, when the replacement of equipment is needed. There are two options. either when the task it performs is no longer needed, or else task to be performed is needed but can be efficiently and still in a better fashion by can be done by a machine that is available in the market. So there are few terms we are using here very frequently: defender and challenger. What are they? Defender is an existing old machine which needs to be replaced. It is called defender because it needs to defend itself. Next is challenger, a new machine that is available in the market which will replace the defender. It challenges the defender and hence the name challenger. Now let us see what are the reasons for replacement. There are three possibilities: physical deterioration, obsolescence, inadequacy. Let us see one by one. Physical deterioration. Whenever products are produced by an equipment, there is every possibility that parts rub each other, because of which wear and tear takes place. This reduces the efficiency and increases the operation and maintenance cost. Obsolescence is a reason that is not internal to the equipment, whereas it is external to the equipment, connected to the outside environment. Any changes in the environment due to that, uh, that is new upgraded technology, machine with upgraded technology is available in the market, because of which present machine becomes obsolete, though it is producing uh, pakka correct. It is working fine only, but would have become obsolete. For example, if we consider PCs, personal computers, when the better RAM with the faster clock speed, more memory possibility, when new versions come like this in PC, then the older versions, though they are functioning very well, they become obsolete. There are two types of obsolescence problems. One is functional due to decrease in demand for the product, and the other one is economic. Similar asset is present in the market capable of producing at the lower cost. Third reason is inadequacy. This also, though the system is functioning fine, the demand has grown so much that present equipment is not enough to produce. So it is not sufficient capacity wise to produce, hence it becomes inadequate, so needs to be replaced. What are the cost components we are considering here? For, as I already told you, the purchase price, also called as first cost, capital cost, etc. Average operation and maintenance cost. Sometimes in the problem it's called as O&M cost. The first letters are taken, O&M cost. So total cost will be capital cost plus average operation and maintenance cost. Capital cost, when we consider, along with that we also consider the salvage value or resale value or scrap value. These are all same: resale value, scrap value, salvage value, disposal value, that is also same thing. So let us see graphically how can we calculate the economic life, how can we arrive at economic life. If you see here, along x-axis life of the machine in years is taken, along y-axis costs are taken. So the average cost, that is average O&M cost, increases as the life increases, and this increment is all more or less same every year, so it is an inclined straight line. Whereas capital recovery cost is high in the beginning, and with the passage of time it keeps decreasing, and later on it becomes almost the same, horizontal. So if you consider the combined effect as total cost, in the beginning it is high, with the passage of time it decreases, reaches minimum, then once again it starts increasing. This minimum, whatever point is there, corresponding to that, if we draw a vertical line, then wherever it reaches the x-axis, that value is called economic life. It is the point where both capital recovery and average O&M costs intersect, or it is the point where total cost is minimum, either this or this. Now let us see what are the types of replacement problems. There are three types. The first type is replacement of an existing asset with a new asset using challenger and defender concept. Second one is, sometimes you find the term RP in the question paper. RP stands for replacement policy for items which deteriorate gradually, like the equipment, machine. There are two types once again within this: when value of money does not change with time, when value of money changes with time. How do we identify? If interest rate is given, then it belongs to second category. If interest rate is not given, then it's understood a value of money doesn't change with time. Third variety is RP for items which deteriorate suddenly. Example is bulb. There are two types: individual RP and group RP. Based on the theory part we have learned, let us solve the problems. Let us read the problem. Consider the choice between a defender that has a defender is the existing machine that has a current market value, that means first cost, purchase value 5,000, and a challenger that can be purchased for 7,500. Challenger is a new machine that is available in the market. Both have a service life of 3 years, same life, with no salvage value. Should a replacement be made if required ROR, that is interest rate of return, is 12%? The operation costs of defender and challenger are given below. Year wise, what are the defender costs, what are the challenger costs? Now, while solving replacement problems, there are two possibilities: either use annual cost method or present worth method. Annual worth method is more preferable because even if unequal lives is there, very conveniently, easily we can solve. So I'm adopting here throughout annual worth method. So let us start with the solution now. Defender, that is existing machine. Let us analyze first. So I've written the side heading defender. Next is, what are the costs? Let us draw the CFD, cash flow diagram for that. The first cost 5,000 occurs always in the 0th year, and since it is cost, drawn downward. And what are the costs associated with the defender? Only those many, let us see. It's only 5,000. Next is, come to the table. Defender costs are first year 1,700, second year 2,000, third year 2,500. Accordingly, they are drawn downwards because costs and first, second and third year costs are shown here. Now we have to solve this. I already told annual worth method will be used. So the formula used is EAC. EAC stands for equivalent annual cost of defender. D is the suffix defender. Formula is capital recovery cost plus annual cost. Here onwards I would have used the abbreviation CRC plus EAC. Why we call this capital recovery cost? Because capital that is invested will be converted into annuity using this particular factor, this particular term. And annual cost, anything else will be converted into annual cost and will be added because both our annuities can be added. Now capital recovery cost formula is P minus S, where P stands for first cost or the purchase cost, S is for salvage value, and then I'll use the marker so that easily I can show. This is A given P, IN is the factor which converts present into annuity, and I is the interest rate, N is the life, plus SI dot is for into salvage value into interest rate. This much is capital recovery cost till here, from the beginning here to here within the square bracket, plus all other costs have to be considered under the banner AC, So which are the other costs? 1700, 1700, 2000 and 2500. Now we cannot consider this as gradient series because there is no increment same. For example, 1700 to 2000 it is 3000, whereas 2000 to 2500 it is, sorry, 300. 2000 to 2500 it is 500. So that is why the gap is not same, not possible to go for increment series. So let us separately consider them and convert them into present worth. So 1700, and the factor used is p given f, which converts future value into present. But what is n value to be taken here? We'll see in the next step. Next cost is 2000, convert that into p, given value is f, using this factor. Similarly 2500. Now outside this square bracket, within this flower bracket, what is this a given p I n? This entire square bracket is nothing but present worth, because f got converted into p here. You can make out this particular factor is meant for it. So this is also present worth, this is also present worth, this is also present worth. All present worth values can be added. Now the cumulative present worth we have should be converted into annuity. So a given p does that. P is the given value, converts that into a. So this entire within the square bracket will be the till here. Entire this much will be the one to be converted into p. Sorry, 1 to be converted into a, that much is p to be converted into annuity. And I, n here to be considered is how many years are there in the given problem, the life of it, and it is nothing but 3 years. So let us see how the I and n values are taken. I though will not change once given in the problem, will not change, 12%. So everywhere 12%, you can make out everywhere 12% like this. I value doesn't change at all. Coming to n, this in capital recovery cost, n should be the entire life considered. Whereas when these individual costs are considered like 1700, 2000 and 2500, when that cash flow occurs, based on that we have to consider n. For example, 1700 occurs in the first year, so that's why n is first year. 2000 occurs in the second year, so 2. 2500 occurs in the third year, so 3. And when you convert this p into annuity, remember once again the complete life of the asset to be considered. So n has to be considered very carefully, logically. So values are substituted. Luckily here salvage value will be there in the last year like this, which is not there here like this. It comes not present means it's understood, not there. So 0 to be taken, p is 5000, and this is the factor value which you get from the table, interest table. You can just check, go to 12% page with 12%, go to the third row where n is equal to 3, and under the a given p column, in the a given p column you find this value. So substitute, pick it and put here, substitute. Next s into I. When you write this I, should be careful. Here the I is 12%, but here when you write this I, it is I after dividing by 100. Whenever you multiply s by I should not be taken in percentage, it should be divided by 100, then should be considered. So if it is 8%, 0.08, 12%, 0.12, like that. Next is similarly for 1700, 2000 and 2500. All these in the bracket values are from the interest table, and this is under the column a given p. So when you calculate, you get the value 4118.4 rupees. This is the story of Defender. Let us see Challenger now. So once again the question is repeated so that it is more easier for us to take the data. Now let us start with the Challenger. Challenger has got the first cost as 7500. So here 7500. Zeroth year first cost means always downward because it is cost, and all other values are taken from the table. Challenger row, we have first year 500, second year 1100, third year 1300. Accordingly 500 corresponding years it is considered and costs are incurred. CFD is drawn now. Next is equivalent annual cost of challenger. Same formula, everywhere it remains same. Only thing is, carefully we have to take n here. First time when you take n here, it should be 3, and next time when you take it is 500, 1100 means corresponding n 1, 2, 3 like that, and I remains same 12%. And here when you take, let us see the values also we have. When you take here, can you make out 3, then 1, then 2, then 3, and here when you take this I, it is 0.12, divide by 100 and then take this one. So that is carefully to be taken, and if it is 2 digits 0.12, if it is 2% 0.02, like that, divide by 100 and take, and the cost is 4058. From the previous slide I have just copied this from the previous slide it is, and present for the challenger it is this much. So how the decision to be taken? Question asked is, should a replacement be made? Should a replacement be made? Should a replacement be made? If required ROR is 12%, replacement should be made or not? Tell me. That's what the question is asked. We are supposed to answer with the justification. So how we should answer? Out of these two, you just see which is lesser, because both are costs. Whichever is less should be preferred. So conclusion, since equivalent annual cost of challenger, out of these two which is less? That of challenger. Lesser than that of defender, replace the defender by the challenger. Whichever is less is preferred. Which is less? For challenger. So challenger has to replace the defender. That is the conclusion. Conclusion should be written neatly with the justification. Why are you saying that so and so machine should be retained? So for that specifically there will be 1 or 2 marks depending upon the question. Similarly, we will solve some more problems, but here I have shown calculation very neatly stepwise. Further, I would have skipped the steps. Wherever it is necessary, I have given the hint. So let us move on to second problem. 3 years back, a machine was purchased at a cost of 3 lakh rupees to be useful for 10 years. So this is regarding the existing machine, which is defender. Present machine in bracket defender. So this is regarding present machine. What is the first cost of present machine? 3 lakh. But how much is shown here? 2 lakh. What is the life here? 10 years. How much is shown here? 7 years. Why? In replacement, we have a cost called sunk cost. We have a cost called sunk cost. This is not very comfortable for me to write here, but still I am trying so that you understand the sorry for this very bad handwriting. First time I am writing like this. So sunk cost, S-U-N-K. What is the meaning of this? Sunk is the past tense of sink. It's already sunk, means it's already incurred in the past, which you cannot change. The costs that are incurred in the past cannot be changed, so should not be considered for the replacement analysis. We are in the present, so consider the present costs. We are doing the decision for the future, so consider the future costs. Any costs that are incurred in the past, let us just omit. So 3 years back should be subtracted from the useful life of 10 years. 10 minus 3 is 7. That is why the life 7. Next, 3 lakh is the cost actually, but let us see further why this 2 lakh is considered. It's a salvage value. Disposal value is 50,000. Its value is 50,000. Its annual maintenance cost is 40,000. Every year 40,000. The market value of the present machine is 2 lakh, in the sense present means how many years over? 3 years over. Now if you try to sell it 2 lakh, you will be getting. So what is the cost of the present machine? 2 lakh. First cost is 2 lakh. That is why this is 2 lakh, not 3 lakh. Very, very important point to be noted. Whenever this kind of sunk cost is given, then carefully should be considered. A new machine to cater to the needs of the present machine is available at rupees 2,50,000 to be useful for 7 years. All these things let us see later. Interest rate to be considered is 15%. So all costs connected to present machine are here. The same formula, but the thing is how much n to be considered, very important. Not 10, 3, because 3 years already over. Past costs and past life we are not going to consider in replacement analysis when challenger and defender type of problems are given. So annual cost is just the annuity 40,000, no conversion required directly, and this is capital recovery cost, this much. Whereas here I to be taken as 15 divided by 100.15. So life to be taken is 7 years. Please note, not 10 years. So in the next step, I have shown the values. P value, first cost, salvage value. A given P will convert P into A in capital recovery cost. That is the factor to be used. Then the 15%, 7 years. And here it is 0.15. And you get the answer as 83,554 rupees. Now let us see the story of Challenger. Challenger, the cost to be considered is 2,50,000. It is available in the market. Annual maintenance cost is 14,000 and the salvage value is 20,000. It's given useful for 7 years directly. Can you make out? It's already given as present market machine available in the market it is. So future life is 7 years. 7 years is considered. There is no question of subtraction. Only for the present machine this kind of sunk cost, already past life will be there. Not for the new machine. Keep this in mind. For the new machine, whatever life given will be considered. Only for the old machine, some time would have been elapsed, so should not be considered that life which is already over. And all the costs that incurred during that duration also should not be considered. So the same formula, only thing is P is 2,50,000, S is 20,000. A given P will convert P into A. S is 20,000 into 0.15 and N is 7. This is A 14,000. Both this is now capital recovery cost got converted into A. So this plus this, and the answer is 72,282.80. So I just borrowed this from the previous slide. Defender it is 83,000, Challenger it is 72,000, obviously less for Challenger. So give the justification, replace the Defender by the Challenger. Let us move on to third problem. Machine A was purchased 4 years ago. Remember, 4 years ago is past life, should not be considered. So whatever life is there, total life, subtract 4 from 10 and draw in the CFD only remaining 6 years for rupees 2,200. It was purchased 4 years ago, so that cost let us not consider. It is the past cost, cannot be changed now, only present and future. It was estimated to have a life of 10 years. So this life, 10 minus 4, only 6 to be considered, and a salvage value of rupees 200 at the end of its life. So let us see how I have drawn the, this is for machine A. Machine A is Defender now. 1 name will be given in 1 problem, but Defender and Challenger terms are the generic terms. So you try to find out in the problem which is Defender and which is Challenger. So here machine A is Defender, machine B is obviously Challenger. Now the initial cost, actually here it is given as 2,200, but note that 2,200 is not considered because it is 4 years ago. How much considered to be considered today? It will be there in the problem. We have to go in search of it. Present, okay, 200 is the salvage value. Can you make out 200 salvage value? 700 operating cost. And important is, please note that 6 years remaining is only considered, not 10. So now let us see how it is solved. Machine, I have not done all stepwise calculations, so both machines I have shown in the same slide. Coming to machine B, that is Challenger, and for that Challenger, the first cost is 2400. So can you make out here 2400, and 400 is the operating cost and 300 is the salvage value. Note that life is 10 years. So it's given that life is 10 years. So uh, the question is 15% MAR, minimum acceptable rate of return, meaning is minimum acceptable rate of return. Here it doesn't have much significance, you take it as rate of interest, that's it. Question is, does machine A need replacement? So machine A to be replaced or not, based on equivalent annual cost we have to decide. So let us calculate equivalent annual cost first. For that, CF days are already drawn, and there is a last sentence saying salesman offers 600 rupees to take the old machine. That should, this 600 rupees, sorry, this 600 rupees should come here. Can you make out? So that is how this is not 2200. Present value and future values have to be considered. So let us see what is the next step. So we got the Defender value 835.70 rupees. Challenger 863.43. Calculations stepwise not shown. In the similar grounds how I explained previously, do the calculations on your own and tally the values. So conclusion is that out of these two, whichever is minimum, that is 835 is minimum, so keep the Defender, don't go for Challenger. Give the justification, that is for Defender it is less, hence continue with the machine A for next 6 years. Annual savings is not asked in this question, but still if it is asked, it is just the difference between these two, that is rupees 28. Coming to fourth problem, a city's data processing manager is considering replacing microcomputer. Connected costs are given here. In this table, end of year 0, 0th year end means beginning of first year. Trade-in value is 12,000, meaning its first cost is 12,000. No annual cost possible in the 0th year. First year annual costs are 28,000 and 5,000. Both are annual costs only, so can be added. 28 plus 5, 33. For the second year, 6,500 plus 32,000. But what are these trade-in values for first and second? Supposing if the system is kept only for 1 year, at the end of 1 year if you sell, then resale value is 8,000. Then second year doesn't come into picture at all. Rather than that, if the machine is kept for 2 years and at the end of second year when you sell, it is 3,000. So in this problem, how do the first year and second year annual costs relate to equivalent annual costs over 2-year period is asked. It is not asked with whether we have to go for Challenger or retain Defender, or when to replace, something like that is not asked. Give the comparison between 3 types of costs is asked. So 3 types of calculations are needed. Equivalent annual cost over 2 years period, then only for first year, then for only second year. So over 2-year period, all the costs have to be considered. 0th year first cost is 12,000. First year, since both are annual costs, we can just add and write. Second year, both are annual costs, we can just add and write 38,500. What are these inclined arrows? Inclined arrows represent trade-in values at the end of the respective years. Usually upward arrows, if they are drawn, they represent income to the organization. Since these are not incomes, these represent trade-in values. Just to show the difference, I have shown the inclined arrows. So don't take these as positive costs, positive income, and don't add them. It is not like that. Meaning is, if the asset is kept only for first year, at the end of the first year when you sell, you get 8,000. Rather than that, if the asset is kept in service for 2 years, and at the end of the second year if it is sold, then it is 3,000. If it is sold at the end of the first year, it is 8,000, then second year costs will not come into picture at all. So when you consider for 2 years range, P value is 12,000 first cost. At the end of the second year it is 3,000, so salvage value 3,000. Years considered 2, 10%, so divide by 100, 0.1. And 38,500 and 33,000 are the annuity separately considered. F, this is at the end of the first year, so for 1 year it is F to be converted into P. Similarly, this occurs at the end of 2 years, so N is equal to 2, that F to be converted into P. Both are P values can be added, and we don't want any P values, we want A. So convert this from here to here. It is P. You use this factor to find A given P, and N is 2 because for 2 years it is happening. You get A. A to CRC we can add. So the value what we get is 41,1606.8. Now let us consider second calculation, AC for 1 year. That means only the first year should be considered. I'll just use the arrow here. Only for the first year to be considered means it is only this much. So 12,000 is the initial cost and 33,000 is the annual cost. Trade-in value or the resale value is 8,000. So for that calculation, note that N taken is, I've used K here just to save the space. I wanted to show all the 3 calculations in one slide. So 12K stands for 12,000, 8K, 8,000, like that. Year considered is 1 because it will be kept only for 1 year assumption, and annual cost included is only 33,000. So answer is 38,200. If we go for only second year calculation, just see it's only this much to be considered. So 38,500 annuity, and this 8,000 will become trade-in value here, 3,000 resale value. So after the calculation, note that once again N is 1 because it is 2 minus 1, 1. It will be kept only for 1 year. At the end of the first year or beginning of the second year, it will be purchased and will be operating for only second year. At the end of the second year, it will be sold. So N is 1. Now 3 values are there. You compare which is least. This one is least. So AC of first year is least. You have to write the conclusion. And out of these two, once again, it is EAC for 2 years is less than AC for second year. This kind of conclusion should be written whenever you are asked to compare the costs. Coming to fifth problem. An existing machine is worth rupees 2,500 today and will lose rupees 1,000 in value by next year and rupees 500 per year thereafter. So existing machine is considered as Defender. Today's value is 2,500. It will lose 1,000 rupees in value by next year. At the end of first year, if at all you sell it, its cost will be 1,500. And at the end of second year, if you try to sell it after keeping it for 2 years, 500 more you will lose. 1,500 minus 500, it will be 1,000. Similarly, another 500 you will lose if you keep it for 1 more year. And at the end of fourth year, it is 500 minus 500, 0. Its operating cost for the first year is 8,000 and is predicted to increase by 1,000 annually. So this is a gradient series. It will be retired in 4 years. Its life is 4 years when its salvage value is 0. A new improved machine. This is regarding Defender. Let's move on to new improved machine considered as challenger. First cost is 16,000. Operating cost is 6,000. Annuity. Life is 7 years. Note that this life is 4, this life is 7. They are unequal, but still, since equivalent annual worth method is used, unequal lives can be compared directly. It's a salvage value 1,500. Life is 7 years. Minimum acceptable rate of return or minimum attractive rate of return doesn't have any significance here. If it is the chapter on rate of return itself, then it has got importance. Here though you can consider it as just I. So I is 12%. Question is, should the existing machine be replaced? Also, if you feel it to be replaced, then when? So we have two questions to be answered. Let us see the first question. So for the defender, calculation is shown for the entire 4 years. So P is 2,500, S is 0. Entire 4 years. These values should not be considered. These come into picture only if you are selling at the end of either first or second or third. So gradient series is considered, convert that into A, then you add to CRC, answer is 10,181.90. Similarly for challenger, for the entire 7 years you get 9,357. Now out of this, which is less? Challenger. So challenger has to replace the defender, but question still stays back, when to replace. So let us answer to this in the next slide. Now you consider for this analysis only defender. These values I have taken from the previous slide, just copied, otherwise I have to move to the previous slide. So just copied the values for defender for the entire life. If you consider how much, for the challenger how much. Further, when to replace, to see that I have to consider only defender. So only defender, AC for first year. So we use AC if it is only for 1 year. More than 1 year we use the term EAC. So 1 year for the defender, P has to be considered 2,500, yes 1,500. Only this annual cost, which is 8,000, should be considered. So 9,300. Now you just compare whether 9,300 is more than this. No, less. So defender should be kept for the first year. If it is more, let us we could have stopped the calculation here itself, but since it is less, we have to go for next year. When you consider next year, once again n to be taken 1, and for the second year, trade-in value 1,500, P is 1,500, S is 1,000, and only this annuity to be considered because only second year. So it is 8,000 plus 1,000, 9,000. So P 1,500 is 1,000, 9,000 is A, you will get AC 9,680. Now you once again compare, is it less than or more than challenger? It is more, so challenger has to come in and replace defender at the end of the first year. So accordingly you write the conclusion, since AC for first year for defender is less, here defender is less compared to challenger, so first year don't change it, retain your defender. But second year, since defender is more, if you keep for the second year defender, you will incur some extra loss. So just replace it at the beginning of the second year itself or at the end of the first year. Now let us move on to sixth problem. Seems to be a bit lengthy. An expensive low volume office copying machine was purchased 2 years ago for 1,200. Anything happened in the past, the life also we are not supposed to consider, the cost incurred also we are not supposed to consider. That is considered as sunk cost. For analysis, we are not supposed to consider. At the time of purchase, it was believed that the machine would have an economic life of 5 years. So I should consider 5 minus 2, 2 is already elapsed, left out 3 years. So life is 3 years. Salvage value 100. Can you make out first cost is not 1,200 because it's already elapsed. So sunk cost we don't consider. Operating cost is 4,200. some type of copier will be needed for next several years. So same company that manufactured present one costs rupees 1500 but will perform the current workload with operating cost 3500. So 3500, its cost is 1500 but some extra calculation is done. I'll just tell you. Company is offering 500 for the old model and salvage value 400. So at the end of 7 years, this should have been 7 years. Now either you see whether this should be 7 or this should be 5. You just check it out and correct it. Now why this is extra calculation? There are two challenges. One is, I will call this as vendor. This is a challenger vendor. Another person is there who has got a challenger to be given on lease basis. So I will call this as challenger lease. So there are two challengers, one defender. This is a peculiar question. Out of these three, which is the best one, we have to select. So there is a problem occurring. This challenger will give 500 rupees as trading, whereas this lease person will not give any amount, but machine can be sold in the market for 300 rupees. So here we always write the value which will be given by the challenger person. Challenger, when he sells a new machine, he'll take back the old machine and that value you write here. But now there are two challengers and two different values. If it was same, there would not have been any problem. Those two are different. One is giving 500, the other one 300. What to write here, whether 500 or 300? This person gives 300. Not this person, but you can sell it in the open market for 300. Few people don't take back the old machine. This lease person doesn't take back the old machine. He says here does not accept trade-ins, but in the open market you can sell for 300. But this fellow, because his new machine is being purchased, is ready to give little bit more, 500 rupees. So either any one have to be written. Out of them common is 300. So least is 300, sorry. So I'll consider 300. Remaining 200 I have to adjust. Where I have to adjust? Wherever whoever is giving 500. Vendor is giving 500. So here I have to adjust. How should I adjust? Actually 500 is the value this vendor gives to this person who is buying the machine. So the one who buys the machine will have to pay 1500 for the new one, but the vendor will give back 500. So that is why this fellow will sell, and this fellow will pay only 1500 minus 200, 1300. Remaining 300 is already adjusted here. So that is why this extra calculation. All remaining I think you can manage. So 1300 minus 400 is yes. Life is 7 years. So you get 3777. Challenger lease, leasing its copy at 1000 per year. 1000 is the lease amount to be given, and operating costs will reduce to 2750. Both are annuities, you can just add, and since 300 trade-in value is already shown, this is the end. Just do the calculation. Annuity, no conversion and all is needed. Both are A already. Add them, 3750. Which is leased? 3750. So lease option is leased. Replace the defender by the challenger available on lease basis. Write the conclusion. Now we'll move on to last problem. A small bridge leading to a proposed industrial park has a load limit of 4536 kilometers. This data is not needed. Like to tell the story is used. The capacity of the bridge is to be raised to 27,216 kilometers. Two alternatives are there for this. They can either reinforce the old bridge or remove it totally and fill it and go for the new one. Two alternatives are there. Present bridge has no salvage value. So let us see what is the safety return. First option I will call it as reinforcement option. First cost is 30,000. Life 10 years and salvage value would be 2000 in 10 years. Let us go to, but these things are not here already, so let us keep these pending. This one, life 10 and 2000, these three things we got it here. Culvert and fill approach to the park would cost 60,000. So it's calculated 6833 we are getting. Culvert and filling has got 60,000 for next 25 years. Age is 25. 25 and 10 unequal, but we can just proceed. I already gave you the reason. No salvage value, fine. In addition, it will cost rupees 2000 to remove the old bridge. Means the person who is going for augmentation of the bridge, if he goes for culvert and filling option, the old bridge he has to dismantle. For that 2000 extra, so to be added to the first cost. Next is maintenance costs are expected to be 2200 per year, less than upkeep for a bridge. In this case, and in this case, if you consider this maintenance cost, here it is 2200 less. So take here it as 0, add 2200 to that, this will be 2200. Here it is 0. Then what is this 6000 and 3000? Annual property taxes and insurance on the improvements will be 1% of first cost. First cost 30,000, 1% is 3,000. First cost 60,000, don't consider 2,000 here, 6,000 is 1%. I is 8%, here two percentages are there, don't get confused. This is I, this is for 1% calculation, one of the costs it is. Which alternative should be selected? So for this 6833 and let us see for this 6408, better to go for culvert and filling. Thank you for your patience hearing. We have come to the end of this class. So all the theoretical concepts once again you go through and the problems you solve, which you can give me as submission. Some more assignment problems I'll just give after part 2. So let us see part 2 in the next